Hello, everyone. Thanks for joining us for the next session of our Spotlight on GitHub Advanced Security. It's application security where developers live, GitHub and Endor Labs. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. And while we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand within 24 to 48 hours right here on the Reactor YouTube channel. With that, I'd love to turn it over to our presenters. Thank you so much for joining us today.
Cool.
Cool. Good to be here. Hi, everybody. I'm Matt Brown. I'm a solutions architect here at Endor Labs, coming to you from Wayne, New Jersey. It's like 40 minutes from New York City, for those that don't know. A little bit about myself. Before this, I dabbled a little bit in cloud security and vulnerability management. I was a very early solutions engineer at another software composition analysis company. And before that, I was a developer. It's good to meet everybody. Great to be here.
Cool. I love the severe lack of energy we have already. Hey guys, I'm Matt Brown. I'm really sad.
Just doing some banter.
Okay. So, hey everybody, my name is Omar Kimbaya. I am a principal field security specialist here at GitHub. And previously, I was working with Matt Brown, who's on this side, at a little company with a purple dog, and that was a good time. We enjoyed ourselves, and then we moved on, and now we're in these different positions. I'm coming to you live from San Antonio, Texas. If y'all know anything about San Antonio, you probably know about the Alamo, and if you know the Alamo, you should probably remember it. So that's just a key thing there. Y'all should keep in the back of your mind. But I'm looking forward to this conversation, Matt. Like, this is a really cool thing that we're going to be able to work together to provide a really great experience for developers, and so they can work on security without having to worry about security. It's all kind of in there for them to work on. So let's get started.
That's right. Yeah. And it's always great to work together again, Omar. I like that you keep me in check. You got to get more energy.
Yeah, man.
All right, cool. So I'm going to get started here. And we're going to pretend to be an AppSec person for a minute, right? We're going to just pretend to do this, and then we're going to get to the coding, I promise. Because what I kind of want to show is, like, when I was a developer, I didn't want to leave GitHub and I didn't want to leave my IDE. Like, those were my two places that I wanted to live in. And if I had, a security issue or security problem, I didn't want to have to go into another UI thing, let me fix it in GitHub, or tell me what it is in GitHub or my IDE, something like that, right? What I want to just show here is to highlight a problem where, especially with security, a lot of companies and a lot of folks will have these things that block builds if there is a vulnerability found. The problem with that is you're always going to have vulnerabilities. It's like, death, taxes, and there's going to be vulnerabilities all the time. It's the only guarantees in life. So it really is. Like,
unless you're in Korea, in which case it's death, taxes, and Samsung. Like,
there you go.
Three things that are guaranteed in life.
It's just, they're always going to be there, and you're never not going to have vulnerabilities. And I think we all kind of have to accept that. But what you can do in order to kind of alleviate that is to say, okay, only tell me about and only have me fix the things that I can, or the things that are like a legitimate problem, that it is actually bad code. And to highlight that, right, there's a project here. You can tell there's vulnerabilities in here, right? But, a bunch of them are tests. There's unreachable functions. Like, there's no fix available for some of them. I can't do anything about a lot of these. So don't break my build if I can't do anything about it. So what we want to do as a security person is just say, okay, I do have to set up these policies, and I do have to break a build if and only if the finding is critical and high, and I can fix it, and it's a direct or transitive dependency. Some people do direct dependencies first. Those are just easier to fix. And it's a reachable third-party dependency, the software composition analysis, right? Am I using the dependency? am I using the vulnerable part of that dependency and it's exploitable? You get the idea, right? If this and this and this and that only break the build. And when you do that, you're going to find that, we're only going to alert and we're only going to really let you know about the things that you can fix in your third-party open source components, in your dependencies. So then that way you can focus on actually building cool stuff, right? So how does this actually look? So let's pull up an application here, right? Java app. And I have my pom.xml, let's say I'm working on a new feature. So let's create a new branch, git checkout, -b. Let's do my new feature, my new bug fix, whatever you want to call it, right? So now I'm on my new branch. And let's say this gets updated. Now, a lot of times, and this is Java, my pom.xml, and Python, you have like your requirements.txt, package.json for JavaScript, your CS proj files for .NET. A lot of times, like this just happens, right? You go and you do import, you make some kind of import statement, and then these get added automatically without you knowing. Like this happens a lot with open source and these third-party dependencies. They can just get brought in, or of course, you can manually add it yourself, but you're not going to go ahead and look up every single dependency and their vulnerabilities, and then all the other ones that get brought in, and all those other ones that get brought in. And if I were to give an analogy of what software composition analysis does, what open source scanning does for vulnerabilities, if everybody, Omar, you know where I'm going to go with this. If everybody kind of remembers back in high school, you threw a big party, right? Your parents come home the next day and it's like, hey, the house is trashed. What happened? What the heck happened here? Well, I invited my friends. I knew that they were cool, but then they invited their friends. And then those friends invited their friends. And then the friends of friends of friends, they're the ones that trashed the house. I didn't trash the house. They did. So
You had friends in high school, Matt?
I one or two. Not that
I
many,
didn't.
but one or two.
It's very unpopular. No one invited me to parties.
Well, I would invite you, Omar. I'll have a party and you can come.
Thanks, brother. Just you and me.
Just you and me, man. Just one weird party. So it's all the stuff you know and don't know that you're bringing into your software through all these open source components. This is what software composition analysis looks for. So I created my branch. I've added my new feature, brought in some dependency. And now I want to go ahead and actually add that in and commit it, right? So let's do that. Let's do commit. We're going to do my new feature. And then we're going to do push it to my new feature. Oops. Origin.
Yeah.
Duh. So now let's create that pull request. Okay. Let's go into GitHub. We'll see we have a pull request here. So now I'm going to say, hey, Omar. Here we are. Check out this new feature. So now, as you can clearly see, I'm a developer, right? I have my developer hat on. I am going in here and I'm actually checking out, okay, I'm going to add this new feature, which is going to be adding these dependencies. As part of my GitHub action, I have a few different things going on here. One of them being my Endor scan. Now, remember, I've gone ahead and I've added this new dependency. And what we're going to do is we're going to test to check and see, okay, in this pull request, has any of these new findings from this new dependency that have been added, do they violate this policy? If they don't, great, we're all done. If they do, though, what we'll then do is say, okay, this violated a policy, and we're going to comment on this pull request. So not only do I not leave GitHub, I don't have to leave my actual pull request either. And again, if this was just going to be, failing on every single finding that you wanted to have there, right? It would break every time. And we don't want to do that. We want to actually build. We want to push out new features. We want to we want to do the fun stuff part of our jobs. Like when I was a developer, I did not like fixing vulnerabilities at all. Like I absolutely couldn't stand it. I wanted to build stuff. So you can see this is done already. We're going to go all the way down after all this fun old Maven stuff. We ran the scan. At the very end, we're going to see, okay, hey, there's an admission blocked by a policy. This is a severe vulnerability that can be fixed. Well, what do we mean by that, right? So let's actually go back into the pull request. I see my pull request, and there's a comment on it. It's like, okay, what is this comment? There's a severe vulnerability that can be fixed as one finding. Okay, well, it's critical. It's a direct dependency. It's a reachable function. Like if I'm looking at this, this is actually legitimately bad vulnerability, right? It gives me a little summary, and then it tells me, most importantly, how do I actually fix it? Okay, let me just update that to 1.10, right? The cool thing about this comment, you can customize this however you want. So if you want to make a completely different template, have it say whatever you need to say, contact this person, this is why this is happening. Maybe it's like, okay, well, if you're using this component this way, we may not be vulnerable. You can set that up in Endor or right in here via Endor as well. You can do all of that. So now I'm seeing this pull request and I'm saying,
Quick
okay,
question.
yeah, yes, Omar.
So can you talk a little bit more about like what a reachable function is, reachable dependency?
Yes,
Like why is that important? Why should people care about that?
this is a great question, actually. So I'm bringing in all these dependencies, right? And I am using some of these dependencies, of course, but I may not be using the methods or functions in them that have the actual vulnerability in it. Why is this important to know, and why is this super helpful? I'll give you the perfect example here. So let's look at this project again, right? And I'm going to go into that pull request, okay? There are 40 findings in here, 40 vulnerabilities. Everybody, I'm sure, knows fixing vulnerabilities is a pain. And now I got to sift through all 40 of these to be like, okay, well, that's a test one. This is okay, but we're also not using it this way. And you get the idea. Sifting, if I get 40 tickets, 40 Jira tickets or 40 GitHub issues, that's not fun. Okay.
Yeah,
We want to narrow.
it's a lot of tickets, but then like what do I work on first? Like what's most
Exactly.
important?
Exactly. And that's where this comes in. It's like, okay, can I fix it? Is it a reachable function? Test dependencies. Let's get those out of here for now. And these are the ones I want to focus on, right? We have a critical and a medium. Now, that policy we set up, that was for criticals and highs. So let's just look at criticals and highs. And now it's 1. And now what we're showing is, okay, you may have gotten 40 findings, maybe warn on all the other ones because you're not using the function that has vulnerability. Maybe using the dependency. But in this case, if you are using the function that has the vulnerability, this is what you want to focus on first. And then we'll show you, hey, this is where you're actually using it. Your main method actually goes ahead, calls Apache Commons, which then goes ahead and calls where the vulnerability actually is. So instead of 40, I'm now focusing on 1. And if you have like all of your findings, like 549 findings, no, I want to go and I want to look at the ones that I can fix, the ones that have a reachable function, no test dependencies, go down to 22. And then if you want to even go further, you can do the exploitability. It's 9. Out of 550 findings, it's 9 that I got to focus on. Okay, that I can handle. Like this, we agree is not good code. It's vulnerable. It's bad code.
Another question, can you
Yeah.
kind of highlight what EPSS is and like why that's also
Yes.
important?
EPSS is another fun cybersecurity, acronym soup that, I can't even keep track of all these things anymore. But EPSS stands for Exploitability Predictability Scoring System. It's the same people that made the CVE, their CVSS score, which is like scale 1 to 10, critical, whatever have you. But what this is saying is, hey, in the next 30 days, this out in the wild, this vulnerability, the CVE out in the wild, has a 97.17 percent likelihood of being exploited out in the wild. So like this is a seriously bad vulnerability. This is like not good at all. This is what you want to fix first. So it's just saying, hey, in the wild, people are like very much exploiting this out there. That's what
I think
EPSS is.
I think another thing to kind of keep in mind. Oh, what's up, Marco? Marco's here. We also used to work with Marco
Oh,
at Sneak.
hey, what's up,
Um,
Marco?
Very cool. And I think Jennifer, I think we might have worked, maybe, I don't know. I don't know if that's like the Jennifer that we worked with, but hello, Jennifer.
Hi.
But Mr. Endor himself is here, the entire planet,
Ooh,
not the moon called Sanctuary
listen,
Moon.
listen.
It's the planet is called Endor, okay?
Getting caught up in semantics.
Anyways, where was I going with this? So think about
Interesting.
the attack surface, right? Like, what are
Yeah.
attackers actually doing, and
Mhm.
why is like this EPSS like important? I mean, so obviously, what most attackers are trying to do is they're just trying to look for the lowest hanging fruit possible,
Mhm.
and so it's going to be very common exploits. It's going to be very common
Yeah.
types of like anything they can just download from the internet and just run and just have bots just do all of this work for
Yeah.
them. That's essentially what's happening every single day, every second of the day. And so to identify these sort of like low hanging fruit, the easiest things for people to
Mhm.
be able to exploit and to remove them, you've taken away a large portion of the attack surface, which at the same time has also reduced the amount of risk that you're running in terms of running these applications out and in production into a public surface, right?
Right.
And it's also kind of very something to keep in mind that the developer is going to be aware of, the security team is going to be aware of, the infrastructure team is going to be aware of. Like, what are some other sort of compensating controls that are outside of the application to help mitigate some of these attacks as well? Because that might be still existing, but all it takes
Mhm.
is one to get past and to exploit this to create a really bad day. So it does help to have this type of score to be able to narrow it down to help
Mhm.
prioritize and then be able to say, okay, based on these criteria, I can specify from like what was it, like 50 down to like one or two or like
One, yeah.
nine.
Yeah.
Like it makes things much more clear in terms of what needs to get done, when it needs to get done, and what sort of impact it has when it gets done.
Right. And this is why we make that policy, because it's like, okay, I don't like, as a security person, security people, they don't want to block people. Like, let's be honest here. Like, everybody wants whatever company they're working at, hopefully, to do well, right? So, but the security team does have a responsibility. And this is that responsibility to prevent really bad stuff from getting out there. And in open source is open source. Everybody can do anything with it, right? And you like, it's kind of crazy when I was first learning how to program, all the stuff that you just don't know that you're actually bringing in and all the information surrounding it too. So not only, okay, obviously vulnerabilities, that's usually the primary goal of any corporation when it comes to their open source. Hey, are we secure? There's also all this other stuff about it that may not be vulnerabilities, but could still introduce some risk. And we can show stuff like that, like, hey, this component here in this application, this is a super old release. It's 38 months old. We should take a look at that. There's no automated build system. This one, there's no closed issues. There's no recent pull request activity. Like, this is a really old component. It's owned by one person, right? What you could do is you can get all this information, then you can actually go ahead and do some more research and ask for, if I wanted to, here's the AI portion of this, right? If I wanted to say,
Just had to drop that
okay,
in there, didn't you?
I know I had to. You can ask with natural language alternative to, and I don't love using Log4j, but I think everybody knows what Log4j is, so it's just way easy. Hey, give me an alternative to Log4j. Give me a component that will create GitHub issues for me utilizing GitHub's API, right? And it will actually show and give recommendations to say, okay, here are the different components. I just said, give me an alternative to Log4j. And here are all the version, and here's everything you need to know about this component and its version. So this is You could go like, before this, you go to Stack Overflow or Google, right? And just look at it, but you don't know what it's about. It's like, okay, yeah, this component does it great. And then further down the line, security comes back to you and says like, hey, this is like way not a good component. Like we need to figure this out. Then you got to start all over again. It's a way pain in the butt. Like, let's be honest here. So if I kind of start off right to say, okay, well, yeah, there's not too much activity around this one, but it's pretty popular. The quality it's not so great, but the findings, security, that's actually pretty good. There's some license risk in here, but there's no vulnerabilities. Okay, yeah, we can use this one, right? This is just a very quick example. So it's a really, really good research tool to be able to like naturally ask, do another one where we say, that example, give me a component that creates GitHub issues from or with GitHub's API.
So one thing while we're doing this,
yeah,
we don't necessarily expect developers to live and breathe inside of Endor Labs, right?
Yeah, exactly.
These are all additional tools that Endor provides if
Mhm.
you want to be able to use them. I mean, the fact of just like asking for alternatives to particular packages is pretty powerful
Yeah.
because then that prevents you from going into like doing a Google search and doing all of that. You can get this information here and go directly to the repository, just like, hey, whether or not this documentation or whether or not what you're reading in the repository or in the doc site is going to be the
Mhm.
exact solution for you. So you sort of like verify it, but it's kind of like a shortcut way to help find this information.
Exactly. That's exactly right. Speaking of which, let's go back in here. So now the comments tell me, hey, go to version 1.10. Oh, okay. That sounds good. So now I can just do 1.10.0, and I could say git add, git commit, and I could say fixing the issue, push my new feature. And now when we do that and that gets resolved, we'll actually end up seeing a message here saying, okay, good job. You've gone ahead and you've actually fixed this vulnerability. And I actually have an example of that here. This is what you'll see. And then you can go ahead and continue and merge in the pull request.
Yeah. So from a developer perspective, like I'm not spending a lot of time in Endor
Mm.
Labs, the UI. I
No,
can if I want to utilize those extra
exactly.
tools. Like that's cool.
Exactly.
But as a developer, as Matt said, like I want to be able to stay in here,
Yeah.
and the security policies that the security team will create inside of Endor Labs will be able to see the results inside
Mhm.
of GitHub. And so that just makes it really easy for us to be able to make the necessary
Exactly.
changes without having to, have, constant security meetings or, to help scale out the security. Because very, very often you have very few security people with
Mhm.
like hundreds, if not thousands of developers. And so
Yeah.
how do you scale that ability? How do you scale out those conversations? How do you scale out those notices and issues and all those things? This is a really great way to do it inside of GitHub so you can see these things and work on them and improve the security stature of your applications.
Exactly. The thing that I always say when folks ask like, "Oh, do I have to use the UI?" No, of course you don't. Anything you can get out of the UI, you can get in the API. Like we built it API first, so we like want you to use the API. If you want to come in, everybody is welcome. Everybody's welcome to use the UI, of course. But you know, use the API, use GitHub. We built this for a reason because we know that people want to stay in here, right? They want to know that. So as you can see here, my new feature, I fixed it. Wonderful. And I don't have to, if I didn't want to, didn't have to go into Endor because stayed in GitHub, fixed it all there. And this applies for things like, container scanning, signing artifacts, grouping these container findings together. Like this has always been a problem where, okay, my SCA tool, my container scanning tool, they're different. Well, we can group them together and lump them together and show you the different layers. Hey, in this container, I have all these vulnerabilities. What the heck do I do about them? Where do they come from? Well, we'll show you the layers and where they actually came from and how they got there. This is where these vulnerabilities came up in this layer, all of that really good stuff. But again, you don't have to leave GitHub for this. You can just stay in GitHub, stay in your IDE, fix what you need to fix. But the important thing here is that you're fixing what you actually like we should fix, and not all this other noise that can either be put in the backlog, don't need to be fixed because it doesn't affect us, right? It's really the main things.
Can you show them the thing in Endor, like
Which
where
thing?
the thing, the thing,
The thing?
where you see like the dependency tree and like how it all like folds out and all
Oh,
that stuff. That's the thing.
so this is for containers here too, but this is a pretty cool visualization of like, okay, where did these vulnerabilities come from? Like how are the open source dependencies actually mapped? So for containers, it can get pretty crazy pretty quickly. I mean, for any of them really, like you should see JavaScript, man. JavaScript. I had one that
Browsers
one
crash
user,
when we show that.
yeah, like 80. I'm not kidding you, 83 layers deep of just dependency hell, of just stuff bringing in stuff, bringing in stuff, bringing in stuff. And you can actually get a visual representation for containers as well as for the open source stuff, obviously. So like same thing here. Hey, Pillow brought in typing extensions, whatever have you, right? But this maps out and shows just how kind of this, and to be honest, this is a very simple one. But you see 1, 2, 3. I know I'm bringing in Pylon. Pylon's bringing in how many dependencies? 1, 2, 3, 4, 5, 6, 7, 8, 9 in of itself, plus God, even more.
Yeah, it gets
So
wild. It's just a cool
it's
visualization,
crazy.
right? Like if you want to be
Yeah.
able to see like what transitive dependencies look like, this is kind of a cool tool to see that. I'm not
Yeah.
sure like how valuable it is for anybody, but I just think it's a really cool tool.
It is really cool to see. A lot of folks, they want to see it on the container level, which I thought was, I never heard that before. They want to see the dependency graph for containers, but apparently a lot of, especially the security on the AppSec side of things, they care about seeing the whole kind of path of, well, where did this dependency actually come from? And we can visually see that and show that, which is pretty nice.
Nice.
Yeah.
All right, Matt.
Yeah.
Ready to get deeper into GitHub?
I'm ready to get deeper into I'm looking forward to this, man.
All right. So let me
See
do
it.
the thing.
You do the thing.
And
You show me the thing.
sharing the screen. There's actually a person in the background, Anna, who's doing all of this. Like, I have no idea how she's doing it. I imagine she's like in one of
It's
those movies
magic.
where like they wave their hands in the air and there's like interfaces that they have to use.
She's Iron Man.
Yeah. She like has Jarvis in the background, all that
Yeah.
crap. Okay. So we are here in our organization. So what we've talked about is a lot of, SCA and a little bit of container scanning that, Endor Labs can provide. And so talk about reachability, exploits, and how to prioritize a lot of these issues and to make it really easy for developers to remediate vulnerabilities in open source packages and also potentially in containers. So what GitHub Advanced Security can also provide are going to be two other things: static analysis with CodeQL and secret scanning. Also, we also have this little thing called code scanning, which allows you to upload a lot of like code scanning results from other tools into GitHub, so you'll be able to see things in line with your code base. So if you're doing something like linting, or if you're doing something along the lines of just kind of like cleaning up your code or looking for code quality sort of issues, you can have all of that put into this platform within code scanning, and you'll be able to see that alongside your code bases. So it's a pretty flexible platform that we have here. So the first thing I want to be able to show is something that a security person would want to create. So similar to creating policies in Endor Labs, we have something called security configurations. And this is how you're going to be able to showcase how, or rather deploy GitHub Advanced Security at scale across your organization. So I'm going to go ahead and scroll down here to Code Security and go to Configurations here. So within Configurations, it'll show me a list of all my current configurations or security configurations that I have. And I have one down here called the Endor demo. I'm just going to go straight into that and showcase some of the options that you have here. Essentially, first things first, I want to make sure that GitHub Advanced Security is included in the security configuration. So whenever I apply this to a repository or a set of repositories, GitHub Advanced Security, or what we call GAS, will be turned on. For the purposes of this demo, we turned off dependency graph and all the dependency stuff we're doing because this is in collaboration with Endor Labs, and so I want to make sure that their stuff gets highlighted. What's up, Ravi? Over there in San Diego. I was in San Diego last week actually for a revenue kickoff at GitHub. So great weather you all have there. It's like 100 degrees here in
Like
San
the
Antonio.
best
But
weather.
yeah, San Diego's amazing. Beautiful place.
Yeah.
All right, so the things that we want to focus on are going to be code scanning as well as secret scanning. And so you can see here that, I can enable it, make sure it just gets disabled, but I want to make sure it is enabled, as well as secret scanning and also private vulnerability reporting, which is a capability for in your public repositories for open source contributors to let you know, hey, you have a vulnerability in this repository or this package that you manage, and I'm going to let you know privately so you can fix it, and then make like a change log or an update to say, like, hey, we've identified this vulnerability and we fixed it, upgrade to this particular version. It's just a really easy way so that you don't get, put on blast on Twitter, for example. And then lastly here, you can set defaults for security configurations, but more importantly, from a security perspective, like I don't necessarily want people to change this configuration. I want to make sure that these features are turned on for the repositories that I care about. So I can enforce this to prevent others from making those changes. But I can also say, you know what, I'm going to leave it up to the repo admins to make changes as they see necessary. Depends on what sort of configuration that you want to create. Once you're done there, you update the configuration, and now you have a security configuration that you can start applying to repositories. So within here, I have a list of different repositories within my organization. I can filter down to, a lot of different types of filters, just to say, like, if something doesn't have a security configuration, something is matches particular repo properties or repo tags or repo topics. It could be a fork, could be like, I want this for all public repositories or all private or internal repositories. Lots of different ways that you can filter down to the specific one that you want. But in this case, you'll see that our Endor GH demo repository here already has this one enforced, or rather it already has that particular configuration there. So I don't have to turn anything on, but I just want to let you know that this is our new way of adding in these types of configurations to make it a lot more scalable for people to be able to use it, and also flexible so they can have different configurations apply to different parts of the repository within the organization.
Yeah, this is a good way to make just developers' lives easier. Honestly,
Mhm.
like it's less Jira tickets. You get less Jira tickets from security. Honestly, GitHub issues, get less things that you gotta.
Yeah, you keep saying
sift
Jira,
through.
and
It's a force of habit. GitHub issues, Jira tickets. You get less tickets. Things you gotta fix.
I thought we were
You
partners
know?
here, Matt. Like,
We are partners. You know this.
all right, cool. So now I'm in my repository. We've already turned on security configurations, so we already have findings from CodeQL. So I can go ahead and jump into my security tab here. And we'll see that we have 128 code scanning alerts. And this is going to be both for Endor and for CodeQL, as well as any other type of code scanning tool that you want to be able to run inside this repository, to be able to get like a much broader view of, some sort of other types of issues that you might have with your code base here. And then we also have some secret scanning findings as well. So there's a couple of things that we've done to help improve the effectiveness of CodeQL and its findings. Because right now, a lot of tools out there are really, really focused on detection. Just tell me where my stuff is. The next step after that is like, okay, you tell me where all my stuff is. Now tell me when I should fix them. Like, help me prioritize them. The step after prioritization is, okay, now help me understand how to fix it. The step after that, you guessed it, is fix it for me. And so that's something that we're going to be implementing, or we have implemented with GitHub Advanced Security. So I'm going to go ahead and look at my CodeQL issues here. And I'm going to select one of my, let's see, there should be like a SQL one down here somewhere. There we go. So query built from user-controlled sources, also known as a potential SQL injection. I'll go ahead and click into this one. And so what this will show me are all of the existing issues that I see in the repository. So we've already done one sort of baseline scan, and these are all the issues that we currently have. And so within this alert, I can see obviously details about the alert and some recommendations on how we expect people to fix it or avoid these types of issues in the future, as well as like some examples of how you could potentially fix this, which is cool and it's good. But there's a step further that we can go, which is to generate a fix. So I can go ahead and click on generate fix. What it's going to do, it's going to take the CodeQL query, it's going to take the findings, it's going to take all of these different tokens, put it together in a prompt, and basically ask Copilot, hey, Copilot, how would you fix this? Like, what are certain things that I can do inside of my code base to address this? While that's working in the background, I'm going to go ahead and click on Show Paths. And what you'll see here is going to be the data flow from source to sync. So as in when the data comes in, and if this data is coming from an external source, we can assume that that data is tainted some way. And then we can see throughout the entire data flow here where that data goes through. So how is that data changed? What touches that data? Where is that data being used? And then once that data actually ends up leaving the code base, so if I scroll all the way down here to our execute helper, SQL helper, and then we're creating the statement, and then we run the statement. So we actually are executing that query to get a result set. That's where our data leaves the code base. So in this case, we're getting information from a user. We are taking that information and then dropping it directly into a SQL statement and then executing that statement. So in this case, this would be a SQL injection vulnerability. So if someone put in some SQL that is malicious in any sort of way, that's something we want to be able to identify pretty quickly. So
yeah, Omar, you saw like those examples, right? That's how people used to provide remediation for stack analysis. Oh, hey, take a look at this example. Take a look at that example. This is way more powerful. I may be stealing your thunder. Sorry, but it's like it's taking context. I know it's taking context of your code too, right? Like it's not just like, oh yeah, try this. It's like no. I'm gonna understand your code and I'm gonna make you a fix that will actually be beneficial to you and will way more likely fix the code rather than just some random example.
You know what's hilarious?
What?
It's a live demo. So
it's great.
Clearly something has to go wrong during the live demo.
Always.
Like this is such a meme at this point. It's goodness gracious. So it's generating a fix suggestion. I'm not sure what the holdup is, but we did do this before just in case this were to happen.
There we go.
I just need to find that particular alert in which we did it. Let's see. I believe it was. Ugh. Don't you just hate it when that happens? Never fails. Never fails.
Somewhere.
Yeah, it should be query built by. I'll just search for it. Query built from user control sources. And then it's one of these. Ugh.
Oh.
There we go. Okay, this is the one that we did. This is the one we did during our practice session. Always have a backup because this sometimes happens. All right, we don't need to harp on it anymore. We all know that this is a live demo and these things happen. So moving forward. So very similar type of vulnerability that we have with this example, with this particular alert, but you see that we have the auto fix here. And within the auto fix, we have that query statement that we were still developing, still working with. And then you can see the error here that we identified it. But if we look on the right side, everything that's in red would be something that we've removed or changed, and everything is green is everything that we've added. And so you can see here that we, instead of just dropping in the data directly into a string and then executing that as if it were a SQL statement, we are creating a prepared statement. And in this sense, this is what allows us to avoid any sort of SQL injections, because with prepared statements, that allows us to remove any sort of like nasty characters that we don't necessarily want to be a part of that SQL statement. And then so from here, I can say, hey, I want to create a pull request with this fix, and I can move forward. I can make edits to it in the pull request, so I don't have to accept this particular methodology. I can use something similar to it, and I can change it, and then I can resubmit that pull request or recommit in that particular branch that we would create with this PR. And then I can make it more fit with our coding standards, for example, because me as a developer, I would know that better than, Copilot would at this time. And this is just going to get better and better and better as time goes on. And a lot of this development has happened relatively quickly. I mean, Copilot only came out like a couple of years ago, and now
Yeah.
we're doing stuff like this. Like, this is rapid development in the AI space, specifically for developer security. So we're really excited about this. So this is the new thing, right? This is something that isn't currently in beta, and we're going to be slowly rolling this out. Now, let's say, for example, that we're looking at things. This is like backlog. What about new stuff? So if I'm introducing a pull request, do I still get the same sort of experience? Like, can I get something that will tell me this is vulnerable and this is how I can fix it? So I'm gonna go in here and I'm gonna look at this pull request. This is from me yesterday because preparing last minute, that's what we do. And in here, well, first of all, I really have to call this out because this was really, really cool. You can use Copilot to summarize your pull requests for you and to create these comments. So as you can see here, this right here is Copilot writing this. I didn't write this. I just clicked a button and Copilot looked at the changes that I made and then created this. And this is my favorite part.
Yeah. We were doing this yesterday, and I was like, whoa, wait a second. Go back to this. And it just gives you a little summary right here. Like this is the first time seeing it yesterday. I'm like, wow, this is
And this is so
pretty
funny.
good.
This method includes several security risks, such as, by the way, Copilot, you need to put a comma before the such as, just grammatically speaking, just please, such as SQL injection and printing sensitive information to the console. And if you look at the code here, that's exactly what I was doing.
Mhm.
I wrote another very similar SQL injection to what's also in that file, but also what I was doing was I was printing out the password to the standard out. If I look at CodeQL, then CodeQL found the issue, identified the issue, and then created an auto fix here. So from this one pull request, tells me what my issue is, show me the paths where it is. I used Copilot to help summarize what this PR is. And then Copilot says, like, okay, based on all of these different things, here is how we recommend you can fix this. And so I can commit this directly. I can edit this within the PR and change a few things, or I can just dismiss this entirely. And say, like, you know what, maybe this isn't right for me, or, we're just going to accept this because this is just for testing purposes, this is for demo purposes, whatever the reason might be, because we just love putting more risk in our applications. And then obviously you can have conversations about these things as well. So it is very, very helpful and highlights the collaborative nature of coding and GitHub and the things that we provide here. We also noticed that one of the things I mentioned was that I did put in another sort of vulnerability here, which is printing out the passwords to the standard out. But if you notice here, the query is saying select the first and last from customers where last equals this and password equals this. I can't print the password to standard out. So if we were to run this code, that would error out because I'm not pulling that information from the database. If I were, it would say select first, last, and password from the customer's table or however we're dealing with the users. And so CodeQL sees that and says, like, oh, there's no way that this data flow will actually ever work. So it's never actually going to print that out. So we're going to consider that as a false positive and filter it out, which I think is really, really cool because now I'm looking at things that are actually exploitable versus a whole bunch of noise that isn't going to really help me or anybody else on my team. So just something to kind of keep in mind. CodeQL is really designed to be high precision as possible. Static analysis has its limitations. No one's going to say that static analysis is going to find every single vulnerability that ever exists. That's not what anyone is saying. And if anyone is saying that in the market, they're trying to sell you something. And it's a used car probably. So from this perspective, we try to make this as noiseless as possible and as actionable as possible for developers, and just to make it that much easier for them to fix these issues where they matter the most. So that's what all this is here. And that's something that we are very excited about. Now, I mentioned we talked about CodeQL and static analysis, AI and Copilot, all these different things. And by the way, you don't need to purchase Copilot to get usage of like the autofix in CodeQL or specifically in Advanced Security. All you need are licenses to Advanced Security to be able to get access to autofix. So you can have this without having Copilot licenses, but I highly recommend getting Copilot because the amount of acceleration that provides developers to get code written and done and pushed and takes away like a lot of the boilerplate, and even just writing a summary for an issue or for a pull request makes it so much easier with Copilot. So it is a developer accelerator. But you don't need Copilot to get autofix with Advanced Security. Just want to really hammer that in there. All right. Talked about Copilot, CodeQL, code scanning. Let's dive into secret scanning. And this one's going to be pretty simple and pretty quick. But the idea here is to say, within my code base, do we identify any sort of like patterns of like, say, like a Salesforce secret, AWS, Google Cloud, Azure, Stripe, whatever it might be? We have a partner program where we work with partners to help standardize what their tokens look like, but also to say we can get those patterns from them and then be able to identify them. So that's a whole thing. So what we also can do on top of all that, so if I jump into my GitHub personal access token here, we can also try to verify these secrets. And so what we'll do is we will, ping that particular partner. Not every partner is doing this. We have a documentation on this, on, which partners support verification of secrets. But obviously, with GitHub, we do. And it says here, this is an active secret. This is actually a token that I created this morning. This token has no permissions whatsoever and expires tomorrow. So if you're going to try to use this, good luck. You get nothing. You get nothing from me. I'm sorry. This is completely useless for y'all. In fact, just to be sure, because I'm very paranoid, I'm going to delete this token as soon as I can.
Everybody's hammering their keyboard right now.
I know. Like, oh, we got to get him. We're going to get him.
Yeah, go.
So this allows us to tell you and help prioritize what secrets need to be rotated as soon as possible. So this helps developers get a better idea of like, okay, what are the things that we shouldn't be doing in our repositories? Now, the thing that I want to talk about next is how do we prevent secrets from being added into the repository? So we have this thing called secret scanning push protection, in which if a developer wants to push code to their repository, and that code has a secret, either it's like a custom pattern that they created with secret scanning, or it's a partner pattern, something along those lines. And within that customer secret that they have it set there, they support push protection. We will be able to prevent that particular commit from being added to the commit history in the repository. Let me show you what that looks like really quickly. So I'm just going to pick my little .env file. This is fine. And I'm just going to edit it here in the browser. And I'm going to drop this other, also live, but soon to be canceled token. So we'll just call it token2 equals that. And forgive me for mixing my double quotes and single quotes. I know that's really going to bother me.
I was about to say something.
Yeah, hold on.
I'm like, hang on.
There. Oh, everybody can just breathe. It's going to be okay.
My anxiety was going through the roof. Oh, don't you do it. Don't you do it.
Get your hand off that shift key.
Whoa.
All right, so what I'm going to do is I'm going to go ahead and commit these changes. And I'm just going to commit directly to the main branch like a boss, right? I could create a new branch and all that. No. I just want to commit this directly to the main branch. Now, I have to remember, did I turn on push protection? Let's see. Yes, I did. I sure did. So
nice.
This is something that from any sort of Git client, whether it's going to be in the CLI or a Git GUI or through the interface here, no matter where, they're going to be notified that, hey, you have a secret in this commit, and we are not going to accept that commit. So it will not become part of the commit history or the Git history within the repository. Go ahead, make adjustments, and then resubmit your commit without the secret in the code base. So this is something that I think most of secret scanning competitors out there cannot do, but we can do natively within GitHub, which is huge. If you want to prevent developers from doing this, this is the way to do it. This is the best way to prevent developers from getting more secrets into the repository. Last thing I want to talk about when it comes to secret scanning. Let's go ahead and cancel changes. If I come over here and I look at other, you'll see here that we have a password. Now, I don't have a custom pattern for this particular password. I don't have anything like to specify this, but instead, what we are doing is we're using AI. Stock prices are going crazy right now because we said AI. Inside of our code base here to say like this string pattern, is this similar or indicative of a secret? And in this case, it is, because we see string password equals blah, 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 blah. And so in that case, we can say like, hey, we're pretty confident that this is a secret and we want to make sure that you're aware of it. And so obviously this isn't something that we can test because we're not going to connect to your Postgres database. And so like, oh, we're in. Yeah, it's real. This is more of a, hey, just to let you know that this is a problem. And we would recommend removing this from your code base and using some sort of like Vault or even GitHub secret manager, whatever it is, keep those out of the code base and then just have them be able to get pulled in at runtime. But yeah, that, ladies and gentlemen, is the other parts of advanced security. So one, Endor Labs, SCA, reachability, exploitability, all of those cool things, all of that can be done and seen and interacted with inside of GitHub. Additionally, you can do your static analysis, you can do your secret scanning, and you can prevent new things from coming in terms of secrets. And you can also fix your first party code vulnerabilities much sooner and much faster. So, Matt, what questions you got for me?
I mean, more of a statement, really. Like, I mean, you and I have been doing this for like
Too
6
long.
years, 7 too long, years, 7
6
years, 8
months. It's been too
years,
long.
6 months. It's like the attitude has always been, security and development, right? You know, and it's a shame because it's like, nobody wants to block anybody from doing their job. Nobody wants to not push out features that make the company successful, things like that. But unfortunately, that's just how it's been, right? And what we want to do is we really just want to, this is going to sound corny, but mend that relationship and to say, look, we don't want to block you. You don't want to block us. We know that you want to push features. We know you want to keep us secure, that kind of stuff, right? We want to make each other's lives easier. All of what we just saw is saying, okay, we know there's a lot of noise. Let's focus on what we can actually do something about and actually keep us secure and actually keep us safe. There's a million vulnerabilities. I don't even know the actual number of known vulnerabilities and exploits, right? It's way too much.
Billions.
In reality, it might actually, no, it's got to be millions probably, but maybe a million. It's like out of all of those, very few actually get exploited. But like you said earlier, it takes one. All it takes is one. We want to help you kind of make it as easy as possible and as frictionless and simple as possible to find that one and to be like, let's just fix this. Let's figure it out. That's really what we want to do. We want to, so what's the term? It's all better together kind of thing.
Yeah, it is. It's really is a better together story. I mean, the way that I try to think about it is security. Oh, we can stop the screen share.
Oh yeah.
Just focus on our faces. Anyway, so the way I like to think about security is the department of business continuity. We want to make sure that the business stays in business, that the business is protected, that we can remain operational and, keep serving our clients, keep serving our customers and provide them the best experience possible. Development is really meant to help increase the revenue for an organization. Like, how do we push out more features? How do we better serve our customers? How do we make these experiences better and all of that? These two things need to work together. They absolutely have to be. But the security team as individuals are difficult to scale in terms of like their skill sets, in terms of like what they know, in terms of how they do things. So using technology to help amplify that, to help scale them out, and to help developers know when to fix things, how to fix things as soon as possible, that's the best way for them to be able to work together, because they can set the policies, they can set the rules on like, this is how we want to help with business continuity. Development says like, cool, we're going to keep building the business and making it better, but we're also want to make sure that this business remains secure as much as possible.
You did have a question, Omar. Can Copilot do, this is actually a great question. Can Copilot do project management for me or incident management? Those are the tasks I'd like to get rid of. Buddy, you and me both.
Yeah, that's our friend Boilerplate. Look out for Copilot Workspace. Like that is something that we're developing right now, and should be coming out in the next couple of months, if not. The way I like to say it, like I don't like to make product promises, but I always say the feature will be available within the next 100 years.
There you go.
Safe to say, if you wait, it should come up. But yeah, more details about that coming soon.
You're not wrong.
Definitely check out Universe this year too. GitHub Universe. We'll
Yeah.
probably have more information about that there too.
Hey, if you need early testers, Omar, I will gladly volunteer for that, because that is something that I would love to also will be available at Christmas. Don't specify which year.
Merry Christmas. Some year.
Some year.
All right, cool. And what website or how do you sign up for the licenses? Definitely, like if you already have like GitHub like Enterprise, definitely reach out to the account team that's managing your organization, and they can help you get that done.
For Endor, we have a free trial, 30-day free trial. There's no like restrictions on it. Test as much as you want, scan as much as you want. Just go to endorlabs.com and sign up there. It's really cool. There's a lot of educational content on there too, like open source stuff, some AI stuff, like what call graphs are. So if you really want to get into the nitty gritty and the technical stuff, we have a whole area there. We also have an organization that's open for anybody to join called Lean AppSec, where there's a Slack channel. There's like CISOs from major corporations there. More than encouraged to join there. You learn a lot if you're interested in security, application security, and other security too. Why not?
Just throw it in there.
Cloud security, all that fun
Physical
stuff.
security.
Yeah. Pen testing.
If you want to learn lock picking, Lean AppSec. Like,
yeah. I wouldn't be surprised if there is already a channel called like lock picking. I would not be surprised.
Hey man,
I'm gonna make it now.
Like another DEF CON? Sheesh.
I know, right? The whole auditorium with the tables.
Goodness. All right, cool. Awesome. I know we have 2 minutes left. Chat, what other types of questions do y'all have? We are here to help.
Yeah. Let's see.
Enjoy the session? I don't know. I think we could have done better.
I don't know. I loved it. I thought it was great. I had fun. I always have fun at these things.
Yeah, this is the best part of our job, is just talking at a computer screen.
Oh, speaking of security, how do you upgrade a transitive dependency to NPM? Okay, I'll try to answer this in like 10 seconds.
Hit it.
Best way is to upgrade the parent component, the direct dependency that brings it in, if it is available. That's usually best practice number one. If there is no fix available for it, a couple different things you could do. You could try to patch it yourself. That's really hard to do sometimes. Sometimes it could be really easy. Completely depends. Or you could swap out the dependency, the parent dependency, or in all honesty, you do research into the vulnerability and it's not fixable. It's not reachable. There's no known exploit for it. It's whatever severity. Just accept the risk, put it in the backlog, wait till fix does become available, fix it. But the easiest way, if it is available, if it's like a minimal upgrade the parent, the direct dependency.
Yeah, there's not a good way to switch out the transitive dependency, because you could break a lot of things if you do.
Yeah. Because that's going to rely on 15 other dependencies, and those are going to rely. So it's like a house of cards, right? You remove one, whole thing could come crashing down. Signaler. I can look into that. See what version number do you know?
I love this. Like we're talking
Yeah, I
directly
know.
to one person.
I know. I'll take a look. Signaler. And if you reach out like on YouTube on the comments or something like that, or if you gave us your email or something like that, we can follow up.
Yeah, we learned the other day that this person over here is like in all of our like reactor series
it.
things. It's like this is a VIP that we're talking to. Just want to
I
let you
love it.
know. Yeah.
Good. Signaler.
All right. There's a new one now. Victory. We did it, Matt. We
there you
did
go. There you go.
I've been waiting for months.
Well, you're good now.
All you had to do is wait for this particular session, and that's all that needed to happen. I don't know. Okay, it had nothing to do with it. But
how great customer service is this?
Thank you for joining. Thank you all for joining. Matt, thanks for doing this with me. This was a lot of fun.
This is
I know
great,
we gotta wrap, but again, if y'all need extra help or y'all need anything, just let us know, and we will be here to help as much as possible.
Thank you all for attending. Appreciate it.
Yeah, y'all take care.
Bye now.
Thanks, everybody, for joining us. Thank you to our presenters for a wonderful session. If you'd like to view past episodes or sign up for future sessions, you can check out the link at the bottom of your screen. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find the link on the screen or in the chat. Today's event code is 23156. And we'll see you at the next one.